So right here we have what we call a PhET simulation, and I'll actually put the link in the class so that you all can visit this site and you all can kind of just kind of use this simulation to see what we're talking about here. So as I mentioned, all kinds of things depending on what the temperature they're in will be solids, liquids, or gases, right? So what is a solid here on Earth won't necessarily be a solid on some other planet where the temperature is just like burning, right? Metals would probably be liquids or something like that in those on those planets. But what the temperature we have here on Earth, these are the way that things work out. These are the way that things are structured, right? So, for example, we keep talking about water. So let's right here go to water. And let's change this to Celsius because in this class, when we're talking about temperatures, we're mostly going to be talking about Celsius, right? So here you see these little water molecules, and they kind of look like Mickey Mouse heads. The red part there is oxygen, and the little white parts right there are hydrogen. That's why it's called H2O, H2 because two hydrogens, and then O because one oxygen, right? So those little white ones are the H2, the hydrogens, and then that red is the oxygen. So this is again why you call it H2O. But you can see right here at negative 127 degrees, it is going to be, and let me start this over again. You see that they're kind of stuck in a place. And let me make this even colder. But even though they're stuck like that, they're still kind of vibrating, right? You see that vibration that we were talking about. But the colder you get it, the slower it moves, right? This is what you call kinetic energy. It just means energy of motion. So if things have a lot of kinetic energy, that means they're moving really fast, and that's because they have a lot of heat. But if they're like this and they're barely moving at all, it's because the kinetic energy is very low. They don't have a lot of heat, right? So that's why food, when you put it in the freezer, it doesn't rot very fast, or it doesn't rot at all, basically, because the particle, there's no reactions happening because you've pretty much slowed everything down, right? So this is what happens when there's no temperature, when the temperature is really low. But let's crank this up really quick and let's turn up the heat. You see the temperature up here is moving really quickly up here. Move it back to Celsius, and let me crank up the heat again, and you see a lot of movement, right? So the more, and right here you saw what was happening is usually when you have ice kind of spreads out a little bit more because of the things that are holding it together. And that's why sometimes you'll put something that is glass and has a liquid like water in it in the freezer, and you forget about it and you come back at night and the bottle has like burst open. It's because it kind of spaces out when it freezes, right? So that's what you saw when you were kind of like when I was reducing the temperature like that. That's like water freezing in that container. It kind of spread out. That's why they breaks those containers, right? Even like a can of Coke or Pepsi, you leave it in there long enough, it's going to burst, right? So let me go back and increase the temperature. And then you see that's more movement, right? You start to get more movement as the temperature increases, and you increase it, increase it, increase it. And then all of a sudden it starts vibrating more, and then it starts moving apart more. And then all of a sudden they're going to start to break apart from each other. And this is like how water turns into steam, right? That's how it boils. It's going to start to shoot up, and they're going to start to space each other apart. And see, there you go. Now the water is separated. The little water molecules or particles are separated from each other. And that's because the heat has broken the bonds that were holding them together. Right? So much energy now and so much movement now. So again, here we have a solid. Here we have a liquid, kind of like the balls of Chuck E. Cheese. And here you have a gas just kind of floating all over the place. And this thing has a lid on it, so that's why they don't just fly out.